Alrighty, we are back at it. Hello, I'm Carter. This is the third installment of writing solutions for the SAT out in LaTeX until Khan Academy hires me. So, let's get right into it. Today we're going to be checking out this problem. We're going to talk through a solution verbally and then write it out from scratch in LaTeX. So let's start with the problem. We have a figure here, and they ask what's the value of x in the figure. So x is up here. It's the measure of angle E. How do we find the measure of x? So the first step is to analyze this figure and identify which congruencies we have already. What do they give us? What do they tell us? We have this side length, EA, is congruent to this side length, CA. They're both 3.6. Do we have any other congruencies? Well, we have DA and BA congruent with a measure of 3.8. How about, so we have two side length congruencies. How about, do we have any angle congruencies? Not directly, but if you recognize here, we have two vertical angles. And if this one is 118, then this one over here on the left is also 118. And that's just because, again, they are vertical angles. So it turns out we have a side congruency, an angle congruency, and a side congruency. When we have a side angle, side congruency, that indicates that the triangles are congruent. Triangle EAD is congruent to CAB. Therefore, the corresponding angle should be congruent. E congruent to C. EAD congruent to CAB, and then angle D and B are congruent. So if E and C are congruent, then that means if we can find C, which we can, then we will know what E is because they should be congruent. And then, so let's go ahead and find C while we're at it. We know that the three interior angles of a triangle add to 180. So if we do 180 minus 118 minus 30, we will get this angle. So let's do that real quick. 118 plus 30 is 148. And then 180 minus 148 would be 32. So if C's angle measure is 32, then E's is also 32. Therefore, X is equal to 32. That's the thought process. That's the flow of the problem. Now let's type it out in LaTeX from scratch. I am going to get rid of my camera, so I'll see you. Let's get a quick screenshot of this. Can't screenshot during this. I can do that. There we go. Wouldn't let me do it a different way. So we have that. So I'll just need to grab that when I open up LaTeX. So we're starting from scratch here. Let's get right into it, baby. We're doing document class article. We're doing use package, AMS math. We're using, what else are we using? Use package. We're going to need a enum item. We're putting an image in, so we're going to need use package graphics. And hopefully that's it. Let's get a little title. We're doing congruence, similarities, and angle relationships. And this is the advanced. Who's the author today? What name am I going with? We'll go Math DeMarco. And we'll go ahead and begin this doc. We'll make our title. And let's check out what we have so far. Okay, beautiful. Looks sexy. Let's start with section 1. Roll on problem 1. The problem, we want to insert this graphic here that we just saved. Let's go to my screenshots. We have our nice screenshot right here. Let's see how it's looking if we just plug it in here. Okay, it's pretty huge, so we're gonna shrink it down maybe a little bit, and we're getting rid of the caption. I don't want that little figure 1 down there, right? Let's see what it looks like now. Okay, it's smaller, but notice it's not below the problem 1. So I realize you can put this little H in here on your figure, and if you use a package float, it should allow your object to float, and so it shouldn't be bound to, I put it at the wrong spot, sorry. It should be with the figure, my bad. There we go. There she is. Okay, so we have our figure. That's cool. And what's the problem? What's the value of x? Something along those lines, right? What's the value of x in the figure? Yeah, that's perfect. Okay. So, we just need to go through the flow of, you know, solution that we just explained. So, let's get a little solution. And I think we said it was 32 degrees. So, let's go 32 to the power of circ. And do that. So, we have a nice solution there. Let's start with a begin enumeration with the options. We'll go label equals Arabic, and we'll make sure to put the backslash here, /, and then let's start with item 1. So begin by identifying any congruencies. It says congruencies is not a word. I also spelled it wrong, so let me try to spell it right and see if that's right. I like the word congruency, so I'm going to keep it. I don't know if it's right. Yeah, who cares? Any congruencies given in the figure. We have, what did we say we had? We had side length EA and CA. So we have side length, what is it, overline. Do I have to do, I think it's that, EA congruent to overline. Oh, wow, okay. Overline CA, and what else do we have? Let's put the other one. Overline DA and overline BA. So this is basically just saying that we have two congruencies so far. Begin by identifying any congruencies given in the figure. We have, let me just put that on the next line so it's very clear. We have EA congruent to CA, and we have DA congruent to BA. Those are like the given congruencies we have, right? And so let me make it clearer down here. I'm just going to say that EA and CA are both 3.6, DA and BA are both 3.8. Do I need to do that? I guess not. But just to show my skills, we'll go ahead and just keep doing that. So I'll just say again that I'll kind of just do these same things. I'll just make sure it says equal. Yeah. I'll go equals 3.6 equals, and then below that I'll just have the other one. Equals 3.8 equals, we'll close it off. Just kind of really highlight what we have here. Oh, something's doubled up there. That's my mistake. Okay, yeah, so this just shows that the segments are equal to 3.6 and 3.8 accordingly. So we have two direct congruencies given to us right away. Indirectly, let's see. I'll just say we also have an angle congruence. That is angle EAD congruent to angle CAB. And this is because they are vertical angles. I also have an angle congruence because these are vertical angles. That's fair. And then we'll just put a similar thing here. And this will just say that the measure of angle EAD is equal to 118 We'll throw a little angle in there, a little degree symbol, I mean, and then measure, and then close that off. Beautiful. So we also have an angle congruence, angle EAD congruent to CAB, because these are vertical angles. Vertical angles are always congruent. Couldn't hurt. Beautiful. Okay. Oh, 118. I forgot the other equal sign. I knew something felt funny. Where is it at? Okay. Looking sexy. All right. Next one. We now have, let's see, side angle side congruence. We now know, oh good, the leaf blower's here. We now know, we know now that triangle EAD is congruent to triangle CAB by the side angle side congruence. We now know that this triangle is congruent to this triangle. That seems fine. Okay, next item. Since these triangles are congruent, each of their corresponding angles must be congruent. Most importantly, measure of angle C, or angle E, I think it is. Yeah, E to C. You can kind of see it there in the first letters. Angle E is congruent to angle C. See how that looks. Since the triangles are congruent, each of their corresponding angles must be congruent. Most importantly, E and C. Okay. Don't like how it cut it off like that. I'm just picky and just want it to look cleaner than that. That's cool. Most importantly, da-da-da-da-da. And so if we find, I'll just say, let's solve. I'll say, if we can solve for the measure of angle C, then we will have the value of the measure of angle E. Okay, that's sounding fine so far. Okay, so that's going to be the next step. We can solve for the measure of angle C by using the fact that the sum of the interior angles of a triangle add up to 180 degrees. Let's solve for C. Just go ahead and do this. We'll go begin an alignment here. And we'll start with the fact that the sum of the angles, C, A, and B, should be 180. So this is going to take a little bit more typing, but that's okay. We'll do the measure of angle C plus the measure of angle A plus the measure of angle B is equal to 180 degrees. And then we'll say the measure of that and that, measure of angle C plus the measure of A is 118 to the circ, plus the measure of angle B is 30 to the circ is equal to 180 to the power of circ. And then we'll just go ahead and add 118 and 130 30, or 118 and 30, that is. So we get 148 to the power of circ is equal to 180 to the power of circ. And then we'll say subtract 180 on both sides, or 148 on both sides. Do it how they usually do it, where they do minus that, minus that. And then, let's back that up, it's bothering me. Okay, so we have that, we have that, we have that. Those cancel, so we have left the measure of angle C is equal to 180 minus 148, so that's a 32 to the power of circ. And that's all we need now. We just need the ands and the equal signs. How's it look? All right, beautiful. So we can solve for C by using the fact that the sum of the interior angles of the triangle add up to 180. Let's solve for the measure of angle C. So the sums equal 180. We know those. We plug those in. We have the 148. We subtract by 148. We get 32. So the measure of angle C. Item. So we have the measure of angle C is 32. Since measure of angle C is equal to 32 degrees. And measure the angle C. Can I find where I did that? I'm too lazy. I'll just say measure of angle C is equal. I'll just say since they're congruent. That works. Angle C is congruent to angle E. Then the measure of angle E must equal 32 degrees. So our answer. And so since E is equal to 32 degrees, then X should be equal to 32 degrees. Our solution is X equals 32 degrees. Okay, that just about does it. It's looking beautiful. It really is looking beautiful. Let's go ahead and make sure it's out of 7 for all these steps here, like so. And let's type in our answer. Let's see how we did. All right, theirs looks a lot tighter. Let's see. DAE forms a vertical angle with that, so the measure of that is equal to that. Okay. Two congruent, two sides equal. Yeah, side lengths equal there. Da. Okay, so they kept it a lot lighter, and maybe we didn't need to go so in depth, but personally I like how I did it. I like how where is it at? I like how I broke it down a little bit more, and it's still, you know, clean looking. Ultimately, it's the same process. Yeah. Okay, anyway, I like their justification. I like my justification. That about wraps up this video. Let's bring back the camera so I can say goodbye. Alright. Thanks so much for following along with this fun geometry problem. Hope you enjoyed it. Hope you learned something. Check out my nice, lovely code here. It's pretty fun. Pretty proud of the work I've been doing. I really want this job. So if you watch this and you're at Khan Academy, give the video a thumbs up and then send an interview my way. Alright. Thanks for watching. See you in the next one, or not. This might be the last one. I think I've made enough videos demonstrating my stuff here. I'll probably leave it at that. Alright. Bye-bye.